I've sent back your section 5.1 homework that you turned in, and I want to talk about some of the comments that I put on your papers. So a couple of things. When you're finding the distance formula states that we have the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, this is an actual formula, so pay attention to the fact that it does not start with a plus or minus. The only time that you are worried about a plus or minus when you're talking about the square root is when you solve an equation. So solve equations. That's when we need to pay attention to a plus or minus square root. So that's like if I've got the x squared plus 3 is equal to 12, which I believe is the same one that I put on many of your papers. You would subtract 3 from both sides. You would get x squared is equal to 9. And then you would take the square root of both sides. And this is where you have to pay attention to the plus or minus square root of 9. And so we would get x is equal to positive or negative 3. The reason why we have to take the plus or minus is because think about x squared equaling 9. I can put a positive 3 in there, and that would equal 9. Or I could put a negative 3 in there, and that would also equal 9. So this is why we have to pay attention to the positive and negative square root when we're solving equations. Now over here, we're talking about distance in this case. And remember, distance is just how far something is from another point. We're not talking about direction. So distance is always positive. It's never going to be a negative value. Think about like length or things of that nature. They're always positive. Distance is always going to be positive. If we talk about direction, that is where we get into positive and negative. So it can be both. So please do not add that plus or minus in there. It's not part of your formula to begin with, so don't add anything in there. Now, another thing that many of things were happening wherever you were solving these, I'm just going to take one set of the points. If I had 1, 2, and negative 3, negative 2. This is actually from problem 20. And I look at the distance. When you're working these problems out, a couple of things. Go ahead and put down the original problem. So, in other words, go ahead and put your x2 minus your x1 squared plus your y2 minus your y1 squared, and you're taking the square root of it. Don't drop off any of your notation. Don't drop off your squares. Don't drop off your square roots. With the distance formula, I could have written 1 minus a negative 3 squared plus 2 minus a negative 2 squared. And I will get the same distance in the very end. Now, as you work these out, don't work these across. In other words, don't keep saying equal, equal, equal on the same line. The reason is because whenever you do an operation, such as I add or subtract these, so negative 3 minus 1 gives me a negative 4 squared. I have changed it in some way. this is still equal to my distance, but it's no longer equal to this right here. These are equivalent statements. So they are equivalent, but they are not equal statements. The only time you can keep going like this is if they're exactly equal. Such as my x equals 3. Those things equal each other. They're not equivalent. And that's why you'll notice that on this, I worked my problem down. When you're working these problems, make sure that you work down your paper and not across. And this may sound a little petty, but this is proper mathematical procedures because you want to pay attention to the fact that you're not constantly doing equal signs and saying that everything is actually equal to each other. Now you'll get -4 squared. Do not drop off that square root symbol. Several students were dropping that off and then just putting it in at the end. You still cannot drop it off. These are still equivalent statements as you work down. Also, don't come here and just put it as over this one. You need to make sure that it goes over the entire problem because it's not over just this first part. And if you stop it right here, what you're basically saying is you're going to take the square root of this 1 and then you're going to add it to 4 squared. Notation is extremely important in these cases. Again, this may sound petty, but I'm trying to get you prepared for paying attention to those little bitty things. Now, at this point, you could go all the way to the bottom, or you could say that this is 16 plus 16, and I'm taking the square root of that, so that's the square root of 32. Now, if I simplify the square root of 32, that would actually be, and some of you did this, you did 32, and that was 16 times 2, so that's going to be 4 square root of 2. And that is perfectly fine. So when you're working a distance problem, and you don't really have to put the D again until the bottom down here, you can put it all the way down, but I would make sure that I at least had these equal signs so that I'm showing that they're equivalent as I go down. Now, pay attention even whenever you do the Pythagorean theorem, because whenever you put these back in, such as this, several of you were saying, okay, that's going to be 16 square root of 2, which becomes 32. These things don't equal each other out. Okay? When you take the square of the square root of 2, it actually just becomes 2, and now you multiply. So you got to get rid of that square root symbol. So again, paying attention to that notation is going to be extremely important to us. Now in the next video, I'm going to talk about the graphing problem so that we can look at those.